Hi everybody, welcome to another video in Math 1332, section 11.3, combinations. Alright, we'll just go straight to definition of a combination. A selection of objects without regarding the order is called a combination. Right, so combination without regard order. So there's no order, or order doesn't matter. And we select an object. So order does not matter. Right. Order does not matter. So in that case, we choose things. Right. Now, assume that we don't have any formula whatsoever. Let's see how it works. Of course, we don't have the formula for combination yet. So we just have to do by counting pretty much. So the first example, how many different ways can a student choose to take two classes out of the list math, physics, chemistry, and biology? Let's say we're not talking about the schedule of the classes. We're just talking about what type of class a student can choose. So she's going to, he or she will choose two of these four different classes. So let's see, what can we choose? Right, I will list here. Let's just keep the math, and then you can say math and physics, math and chemistry, or math and biology. There are three of them. You're going to need to take two of those. Next, if you don't want math, you can start with physics, and we choose chemistry. By the way, physics, chemistry, or chemistry, physics, same thing. So that's why we only go forward. Like math, physics, math, chemistry, math, biology, I don't want to go back. So physics, chemistry, and physics, biology. And then chemistry and biology. Right, so when we list like that, we see there are 6 possible ways. Once we get the formula, we'll go circle back to this. But for now, we count there are 6 different ways. So 6 possible options. Right. Now, so up to this point, we don't have any formula for combination. But it's just like the permutation in a way that there are a few things we can choose, and then we put in some certain position that we can have. Right. But the main difference between the permutation and combination is combination order does not matter. Permutation order does matter. Right. Now, determine if the following are permutation or combination. So that depends on order does matter or not. So a 5-digit passcode must be chosen between 0 and 9. Right. Have you ever tried a password? Have you ever tried to interchange the character on the password? I'm sure it will not work. So in that case, order does matter. Permutation. A committee of 5 students are selected from a class of 30 students. Alright, even though when you select the student, you select the first one, there's 30 options, then the next one 29. However, this is a committee. In this, just say committee of 5 students, so the roles are the same, right? So the student choosing first, we do the same thing as student choosing 5th. In that case, the order does not really matter. Or I should say here, rows are the same. That means order does not matter. If order does not matter, it is a combination. to select 3 kind of meats out of 6 to put in a pizza. Alright, I know what you're thinking. If you, I'm not sure about when they make a pizza, do they put all the meat together and then just put in the oven? Or they actually, depends on different type of meat, some will cook faster than the other. So they might want to put something that easy to cook first. So that depends on the situation here. I would just assume that you order your pizza online and you choose 3 kind of meat out of 6. In that case, you don't care really how the chef will put the meat on the pizza. As long as you have those meat, that will be fine, right? So in that case, again, order does not matter. That's the combination. Next, to award 3 medals to race. By the way, if it is combination, here we can say we're going to select 6 out of 6 for 3. We choose like 3 out of 6. This select 5 out of 20, and this permutation 5 digit passcodes from 0 to 9. Right, and because this have to write one important thing here: no repetition. Otherwise, this is not this formula. No repeat. Okay, that's important. Right. So, otherwise, that's what we have. Next, to award 3 medals to the race of 8 people. So in this case, definitely order does matter. It should be bronze. Sorry. So order does matter. That's the permutation. So here we choose 8. Choose 3 people out of 8 to have certain order. Right. So the formula for combination is this. So we choose an object, take an R out of an object, and the formula is of course there's no replacement, combination, and this is this formula. Very important when we say order does not matter. Where we say combination, never do the problem by giving a slot like this. Combination, we're not going to do that. Not going to give a slot like that for combination. Right, so order does not matter. Right, now we have some example. While studying abroad 1 semester, Trent is required to visit 10 different cities, so then 10 to choose from, and he plans to visit 3 out of 10 over a long weekend. How many different ways can he choose 3 to visit, assuming that the distance is not a factor? Right, that is very important. In reality, that may not be the case. Let's say if you want to visit Dallas, Austin, and Houston, for example. You don't want to go Dallas, Houston, and then back to Austin, right? So there's some certain orders. It's much easier to do. Right? Dallas, you ride to Austin, and Austin, you ride to Houston. That's more convenient, for example. But this case, we throw out the distance. Doesn't matter. Just pick 3 names out. Doesn't matter how close or the distance travel. Doesn't matter. So in that case, how many different ways you can choose 3 to visit? Assume that the distance is not a factor, right? So if that is the case, order doesn't matter. So that's going to be a combination of 3 out of 10. And for this, I'm just going to use the calculator. 10 math combination of 3 out of 10, and that's 120. By the way, we did say the first example, when we have the formula, we circle back to it, right? So now we have 4 object, 4 subject, and we're going to pick 2. We can use this formula here, or we can just use the calculator. I'll just use the formula for once. 4 factorial over 4 minus 2 factorial, and then 2 factorial. 4 factorial is 1 times 3 times 2 times 3 times 4. 1, 2, 3, 4. That 24. Four minus 2 factorial is 2, and 2. So we have 6. Very consistent to what we have here, right? So combination of 3 out of 10 in this case, I just use a calculator, right? Next, a club has 20 people, 12 women and 8 men. How many different ways a committee of 4 consists of 2 women and 2 men from that club? Right, so we have. So first we're going to choose 2 women out of 12. And then we choose 2 men out of 8. Right. That's what it is, right? And then of course we said this time is a committee. Usually if you see the committee, the roles are the same. So the role of each of the men are the same. The role of each of the women are the same. Actually the role for each of them will be the same. But the reason we separate like that, so we say that if we want to choose 2 men out of 8, that combination of 2 out of 8, and 2 women out of 12, that combination of 2 out of 12. And whatever you choose for the women doesn't affect what you choose for the men. So in that case, we just multiply them like 2 different states. You choose the women first, 2 out of 12, and then choose 2 out of 8 men later. So that's all we do. Right. So 12 combination. So combination of 2 out of 12, that's 66. And combination of 2 out of 8 is 28. So you multiply them. $18.48. Right. So that's how many different ways a committee can be formed using 2 women out of 12 and 8 men out of 8. 2 men out of 8. Right. Similar problem. A 4-person crew from the International Space Station is to be chosen from a candidate pool of 10 Americans and 12 Russians. How many different crews are possible if there must be at least 2 Russians? Okay. Now there are 4 people, and 2 of them must be Russian. So, what can you choose? Right, so you can choose 4 American. At least 2 Russian, then the crew of 4. So, you can choose 2 Russian, then 2 American. Or you can 3 Russian and 1 American. Or 4 Russian and 0 American. So that's what you can choose. Those are the options. Because you want at least 2 Russians in that International Space Station. Right, so in that case, those are all the scenarios here. This is the scenarios, not the stage. The stage is you do first, then you choose another state. This you can either go with this scenario, or this scenario. You can only pick one of those 3. Right? That's the difference. Now if you put 2 Russian out of 12 Russian, that combination of 2 out of 12, and then you pick 10 American. 2 American out of 10. Right, so just do that. Already have 12C. That would be 66. And 10C2. 45, 66 and 45. At 2970. Right. Now, if you want to choose 3 Russian out of 12, then you only have one option for American. In that case, this should be 10, right? You could choose 1 out of 10, so this is 10. But we can just write like that. I'm just going to put everything at once here. 12 combination. We're going to pick 3 out of those. So that's how we choose the Russians. American, we choose 1 out of 10. That 10 option. That obvious, we don't even need. That's 10C1, which of course is going to be 10. Right, just that. 2200. And then next, we choose all 4 Russian. And then you don't choose any American, so we just leave that part blank. So just 12. C4. 495. Then you can just add all of this up. And that's 56, 65. And notice that these are 3 different scenarios. We can go with either one of them. It is not the stage. When we talk about the stage, we have to go through all the stage. Like pick on the Russians and then pick an American. We have to go through all of that. But in this scenario, we can only go with each case or each scenario here. So that's the difference between the two. And talking about difference, you have to be able to distinguish between combination and permutation. Once again, combination order does not matter. Permutation order does matter. And with that, we finish section 11.3 in Math 1332. As always, thank you for watching.